welcome back to another video. Today will be a physics paper 1 revision. Just a quick final thing, I've got my notes here ready to quickly go through and hopefully this will be up for at least 5 o'clock. So, to start off with, your paper is 1 hour 10 minutes long and it covers these topics right here. Okay, so and also I'm gonna go through some core practicals that you need to know for what's inside, and also just some general advice. Okay, so I'll start with the core practicals. Okay, so our first core practical in the physics paper 1 is going to be investigating force, mass and acceleration. There's actually 2 methods, investigating mass and investigating force. So, step A, you're going to prop up one side of the ramp, place a trolley on the ramp, adjust the slope of the ramp until the trolley starts to move on its own. Then you're going to keep the ramp on that slope the whole investigation. Next you're going to set up a light gates and pulleys with string to hang the mass hangers from. We're then going to stick a piece of card on top of the trolley. You're then going to measure the length of the card. Then you're going to find the mass of the trolley, then put a mass on the end of the string. You'll keep this the same for all the tests, so the force is equal. Then release the trolley and get the speed from the data logger. Also write down the time taken between the 2 light gates. You're then going to put a mass on top of the trolley and repeat step E. Then we're going to repeat for all the other masses on top of the trolley. Okay, so next we're going to investigate the force. So we're going to use the same method that we used for mass, keeping the overall mass the same by starting off with a stack of mass on the trolley and take one off and add it to the mass hanger each time. Keep transferring between trolley and mass hanger till all the masses from the trolley have been transferred to the mass hanger. Okay, so that's it for investigating force, mass and acceleration. We can then move on to investigating speed, frequency and wavelength of waves. So there are different methods for this. We can start off with solid, then we'll move on to liquid, and then we'll move on to gas. Okay, so we'll start with solid. So in a solid, you're going to set up a metal rod hanging from retort stands using rubber bands like shown in the diagram. Then you're going to download a frequency app on your phone, hit the metal rod with a hammer so it vibrates. You're then going to use the frequency app to measure the frequency of sound being given off. The wave that is produced is the first harmonic. The wavelength is double the length of the rod. Measure the length of the rod and calculate wavelength. You're going to calculate the wavelength by using the equation V equals F times lambda. Okay, so that's investigating it in a solid. We can then investigate in a liquid. So the first method is going to be setting up a ripple tank and attach a ruler next to the screen you are projecting onto. Switch on and adjust the motor until you can see at least 2 complete waves appearing. The bigger the wave, the smaller the impact of any wavelength measurement error will have on your calculation. Count how many times the waves pass a point in 60 seconds. You're then going to divide that by 60 to work out how many times pass each second. That is going to be your frequency. Then you're going to take a photo of the screen with a ruler next to it and use this to measure the wavelength. Then going to calculate wave speed again using the formula V equals F lambda. So, investigating speed, frequency and wavelength of waves in a gas. So there's 2 methods for gas and I'll go through both now. So we're going to measure a distance from a large wall or building where you will receive an echo of sound. One person's then going to hold a stopwatch and another 2 wooden blocks. Bang the 2 blocks together and start the stopwatch. Then stop the stopwatch when the echo is heard. Then calculate the speed of sound using the equation speed equals distance divided by time. And then for method 2, we are going to set up 2 microphones apart from each other and measure the distance between them. Attach them to either an oscilloscope or data logger that can record the sound waves received by each and will show the time between the 2 waves. You're then going to produce a sound a set distance away from the first microphone, and then use the oscilloscope or data logger to determine the time between the sound reaching the first and second microphone. Then going to calculate the speed of sound again using speed equals distance divided by time. Okay, so the last core practical that you need to remember for your physics paper 1 is investigating refraction in glass blocks. Okay, so the method for this is going to be place a piece of plain paper on a desk, set up a power supply, ray box and a single slit so that you can shine a single ray of light across the paper on your desk. Take care as the ray boxes could become very hot. That would be obviously a precaution that you could take. You're then going to place a rectangular glass block on the paper and then draw around the block. Shine a ray of light on your block and use small crosses to mark where the rays of light go. Then you're going to take the block off the paper, use a ruler to join the crosses to show the path of light and extend the lines so they meet the outline of the block. Join the points where the lines entered and left the block and show where they travelled inside the block. You're then going to measure the angles of incidence and refraction and then measure the angles where it left the block. Then you're going to repeat steps C to E with a ray entering the block at different angles and move the ray box so that the light ray reaches the interface at right angles. Note what happens to the light and leaves the block. Your apparatus for that then is going to be a ray box with a single slit, a power supply, a rectangular glass block, a ruler, a protractor and plain paper. That is it for your core practicals chemistry paper 1. Not chemistry, physics paper 1. Let's just roll the B-roll for my exam dates and exam things. Other exam boards are the other revision dates and dates are here. Okay, I hope you enjoyed, guys. You're gonna smash your physics tomorrow.